Hi everyone. So LeetCode Weekly Contest just finished, and in that contest there was a problem: maximum product of the length of the two palindromic subsequences. So in this problem, like we have been given a string S, and we need to consider two disjoint palindromic subsequences. So disjoint means like there shouldn't be any character common in them, and we need to multiply the length of these two individual palindromic subsequences to form a product, and we need to return the maximum product possible under this scenario. So for this, for example, like this is string lead code com, and the answer is 9 because the optimal solution is to choose two palindromic subsequences each with length 3. So one will be ET and one will be CDC. So we can see that this ETE and CDC. So in these two subsequences there is nothing in common. So this is a valid choice. And here in this is string BB, like the optimal solution is to choose one is string B and one another subsequence B. So the answer will be 1 into 1. And here in this string, the optimal solution is to choose the two subsequences each with length 5. So one will be this ACCCA and another will be XXC double X. And like this problem will appear too hard after seeing the description, but if we'll move to constraints, we can see that the length of the string as is only up to 12 characters. So this gives us an idea that we can brute force this solution, because if we'll consider the when we can consider every possibility of this character belonging to first subsequence or a second subsequence. So if we'll be doing this, this thing will give us, like, suppose n is the length of this string s, then this will take 2 to the power n combinations, and 2 to the power 12 like is quite a small number. So 2 to the power 10 is 1024, so 2 to the power 12 will be 1024 into 4, so 4096. So we can see that it is much smaller than 10 to the power 6 or 10 to the power 5. So we can easily brute force, and after dividing this to each, what we can do, we can divide this string s into two strings, and we can find the maximum longest palindromic subsequence for both of them, length of the longest palindromic subsequences for both of them, and we can multiply them, and from all these combinations we can take the maximum product of them. So this will be the algorithm. So for the total combinations will be 2 to the power n, and for finding the length of the palindromic subsequences, it will take us again and n squared. So the overall time complexity will be n squared into 2 to the power n. So this is quite fast to pass all the test cases. So we can implement it. So the first of all, we'll be doing what we will be calculating the length of the string s. So first, if this length is 2, we can return 1. So optimal choice in this will to make two subsequences each with length 1, and yeah, any answer bigger than 1 is not possible in that case, because if we'll include two numbers in one subsequence and 0 in one subsequence, then it will make the product 0. And now we can consider all the possibilities. So for generating the two strings, I'll be using the approach of using a mask. So I will be using a bit mask, and if for a particular bit position, the character is 0, I'll be including it into the first string, and if at particular position the bit is 1, bit is set, then I'll be including it in the second string. So I will call it mask, and it will go from 0 till 2 to the power n minus 1, and I can do mask plus plus. So now we have got each mask, and now we need to form these two strings. So I can call first string as s1, and I can call the second string as s2. Now I'll be iterating over that mask, and for that I'll be using this variable j. So I'll be checking whether the mask, like particular bit position is set or not. So if it is set, then I will be including the present character in second string. Otherwise, I will include it into first string. So now we will have access to this S1 and S2. So now we need to calculate the length of the longest palindromic subsequence of these two strings. So I will be using a variable current for storing the product of these two lengths. And for calculating the length of the palindromic subsequence, I will be using a 2D like 2D vector dp, and this dp is like basically calculate, it will be basically calculating the longest length of the longest palindromic subsequence if we are considering I characters from front and j characters from back. So this state will basically contain the information of what is the length of the longest palindromic subsequence if we are considering I characters from front and j character from back. So basically we know that for calculating the length of the longest palindromic subsequence, we can find the length of the longest common subsequence of the original string and the reverse string. So the length that will we get as the answer is the length of the longest palindromic subsequence. So I will make it I will keep the sizes n+1 and n+1, and now we need to calculate the palindromic length of the palindromic subsequence for each of these string. So first of all I will be calculating the length of each of these strings. I'll be calling it x and y. We can also use p and q for that, and I'll be using two nested loops, and each will basically represent. So this I will represent the number of characters from the front, and this j will represent the number of characters from the back. So now we will be doing some standard implementation. So we will be checking whether the character is same or not. So if the corresponding characters are same, then this dpi comma j will be equal to 1 plus dp I minus 1 j minus 1, and if it is not, then this dpi comma j will be equal to max of dpi minus 1 j dpi j minus 1. So in the end we will get the length of the palindromic subsequence as dpx comma x. So we can multiply it into the current product, and now we need to find the length of the palindromic subsequence for string like this string s2. So this code will be same, just we need to replace this x with y and s1 as s2. In the end we can multiply this current with dpy comma y, and now we need to update the maximum product. So I can have a vector variable for that. I'll call it max product, and I will initialize it with 1, because 1 is always possible if the length is greater than equal to 2, because we can always consider a subsequence with one length and another subsequence with one length, and this max product will come out to be 1. So we need to update this max product. Now we need to return this max product because this is the required answer. So I'm getting some sort of runtime error. We can check what is, yeah. So it should be y minus j, and we can again check it. So we are getting correct answer on the sample test case. We can submit it. Yeah. So it got AC. Thank you guys.